Good afternoon, class. In today's video, what I'd like to do is to go over an example problem from stoichiometry, and this would be number 1 in the stoichiometry example problems. So in this problem, the question is, how many milliliters of C5H8 can you make from 366 milliliters of C5H12? And of course, there are some given information that I gave at the top of as the prompt of the question. So there's the density of C5H12, which is 0.62 grams per milliliter. The density of C5H8, which is 0.681 grams per milliliter. The mole ratio between mole to mass ratio of C5H12 and C5H8, 72 and 68 grams per mole respectively, as well as the decomposition reaction between the two, the decomposition reaction in order to show you the mole ratio, which is 1 to 1, instead of 1 to 2 when it comes to the hydrogen, which occurs in later problems in this problem set. So, how do we actually deal with this entire question? And so, I'm going to take you through the long version of this. I'm going to try and go through all of these different, all of the different steps in detail, and just know that you don't have to do all of these steps throughout this entire process. Every single problem does not have to be like this, but it is good to do this at least at first for that first problem, and every so often just to make sure that you're still doing the correct steps. So let us begin. We start off with our, and sorry, before I begin, I should also mention this really works simply by the whole goal of this is to go from milliliters of C5H12 all the way to milliliters of C5H8. So that's this, all of this work that you see is the process to get that one thing, that one conversion, which is exactly what this problem is. So let us begin. We start with our original quantity, 366 milliliters of C5H12. Then what we're going to do, we need to do this strategically, because to go from milliliters to milliliters is actually not that easy. We need a unit that is distinct enough that it carries information about both of these substances, but also general enough so that I can convert from one substance to another and without loss of information. And in this case, that unit is the mole. So this part right here is exactly where the conversion will take place, and that's going to be super important right there. So here we go. We're going to start by converting milliliters of C5H12 into grams, and so to do that, we need our density, and that's why I gave that over here. So we multiply it by the density. Notice that milliliters of C5H12 cancels with milliliters of C5H12, and so just like 2 divided by 2 is still 1. Same thing with this, milliliters of C5H12 divided by milliliters of C5H12, still 1. So in this case, so normally, some people might think, oh, but if you have grams, isn't grams a fairly neutral unit where it doesn't have anything? No, not in this case. In this case, the reason why I can't use grams to go through the conversion is because these are grams of C5H12. They're not grams of anything, any generic substance. It's grams specifically of C5H12. So it's a specific unit to this chemical, so I need to also convert that. Moles of C5H12 is actually the same as moles of C5H8. Or just like the same way as a mole of pennies is the same as a mole of air molecules. They're all the same, it's the same number, you just have to, it's just talking about different substances. So, that's where the whole heart of the matter is, right here in this middle part where I convert from moles of one substance to moles of another. That's the link between the two substances. So I put in the information that I got over here, right over here, and now of course why is it inverted from where it was before? The reason why is because I'm looking to get rid of this grams of C5H12. In order to do that, I can't multiply by grams of C5H12, or I would square the unit. So that doesn't work. What I need to do is I need to divide by this mole ratio here in order for these grams of C5H12 in the numerator to cancel out with the grams of C5H12 in the denominator. So now that I've done this line of work, I've converted 366 milliliters of C5H12 into moles of C5H12, and we get this number here. Now, some of you may wonder, why are you keeping all of these numbers in here? Significant figures would tell you that it should only be about 3. 2 to 3 is about the number of significant figures you should have. And you have a fair point. However, we are still in the middle of this calculation. And so for me, I don't like to do any rounding in the middle of a calculation. So usually you would have done this on your calculator. So keep this in mind. Whenever you're doing this on the calculator, just leave the number as it is and just keep going with it. Don't try to save the number, round it or something to make it look nice in the middle of the problem. Just keep it as awful as that looks. Just keep it as it is and just keep going with the math. And then at the end, at the very end, then you can do stuff with it to make it, to round it to its nice significant figures place. So we will now continue on that second line. So we have 3.1516 with the line over it, moles of C5H12, and 1 mole of C5H8 is the same as 1 mole of C5H12. So that's where the connection is, that's the link. Now we can start the actual work of converting from moles of C5H8 all the way to milliliters of C5H8. First though, I have to go back through the mole ratio and multiply to get grams of C5H8. So I did that mole ratio here. And then because I'm running out of space, I went to the next line. So I have 214.313 with the line over it, grams of C5H8, and I divided that by the density of C5H8. And the reason, again, because I don't want grams of C5H8, I want milliliters of C5H8, and that's why these two units right here will cancel. So when you actually get all of this done, you'll get something approximately your answer will be about 314.7 milliliters of C5H8. Obviously continues further than that. So that's why I put the approximate sign right over here. Right, that's why this is approximately equal to this answer. However, I did want to give you the answer in significant figures. So to get the answer in significant figures, what you need to do is you would need to round it to the 3 significant figures that are given in the problem. So that's why the answer comes out to 315 milliliters of C5H8. And that's why I left that little note over there for you. So that's how you solve this problem. Again, you don't have to do this whole method the whole time, every time. As long as you're okay with how this method goes. If you can streamline it, that's great. But for the first few problems, you should practice this because this technique will help you and it will save you a lot of headaches in future problems. So good luck in your studies, and I'll see you next time.